Okay, so this is the continuation of the solid waste problem, 18.1 notes. Um, so yesterday we talked a lot about, sort of like kind of what's gone on through the years and what makes up the trash and just generic stuff like that. Um, so today we're going to talk about landfills and different styles of landfills. Okay, so really, they sort of categorize them into two categories. There's open air landfills, which are an older style of landfill. Typically, and this is sort of along the lines of what Jeremy was saying too, is like typically in open air landfills, everything is just kind of like piled in one area with little to no covering or anything like that. Um, and the ones even before that, I don't know if you guys, if anybody used their book or saw, but there was a picture in the book of a New Orleans dump, or if you're from down there, Narlands, a Narlands dump. Um, so it's a burning dump, uh, which is what they were talking about, like pre 1960s. Basically, just dump all the trash and then they would burn it, and there's all. I mean, I think I think it's pretty obvious that there's a whole busload of environmental issues with that. Pretty much the worst thing you can do because there really also weren't any regulations about like what you threw away. So I mean, you're talking pre '60s, you're talking like lead paint and um, all kinds of fun stuff that left people within a 50-mile radius with children with three arms and one leg or something. Um, so uh, yeah, just all kinds of really bad stuff from that. So the hills have eyes. Um, the open air landfills are a little better than like an open air burning dump. Not a ton, but um, the benefits of open air landfills would be convenient, cheaper to maintain because you're just dumping all the crap in one spot, right? Um, and here's a big one: faster decomposition. Stuff would decompose faster in an open air landfill. Okay. Drawbacks: pollution, tons of it. Water source pollution, uh, trash transfer to surrounding areas, blowing into surrounding area stuff, air pollution from burning, any of those things. Okay. Leachate is a drawback. We'll talk about that in a second. What leachate is. There's a large space requirement because you're essentially just kind of like piling stuff. There's no real management of it. Um, can attract animals and scavengers and siting issues where to put them. Like nobody wants that near them, right? Uh, okay, so what's leachate? First of all, before I get into what leachate is, let me ask you guys this: do people understand like where water comes from, like that we use? Anybody? Yeah.
It probably mostly comes from the ground.
Yeah, groundwater. So, and I asked this because a few years ago I kind of found out that there were at least a decent number of students that didn't really know how that works. So, groundwater, essentially, what happens is when it rains or snow, you get snow melt or any kind of precipitation. Um, what happens is that fills up, so it goes down and it filters down through the soil and all that kind of stuff, right? It, as it says here, groundwater fills the spaces between soil particles and fractured rock beneath the Earth's surface. So it kind of settles down. And what ends up happening is you get a you get different layers of different kinds of soil and rock material in the earth, and some layers do not allow water to pass through it. So that's what's like. See this? It's kind of, I don't know if it's hard to see or not. It says confining bed. This confining bed layer. A confining bed layer is a layer that water really can't pass through. So like clay is a big one. You get clay. Clay is really dense, and water can't pass through it. Um, Sometimes, depending on where it is, if you get more dense rock layers that aren't fractured, that would do it as well. But what happens is water gets trapped in those layers, and that creates what are called aquifers. An aquifer is just basically an underground source of water. Now, groundwater, so there's aquifers and then there's like groundwater in general. To get an idea of kind of how groundwater works, think about being at the beach, and I'm sure you've all done this at some point in your life, hopefully. But you're at a beach and you're digging a hole because that's what you do at a beach, darn it, right? Like you got sand, you dig a hole. So and you're getting, oh man, I'm like really going to town on this. You get a nice big hole, and then you hit a point where it starts to fill up with water, right? And like no matter how fast you scoop it, like just water just kind of seeps in and then it starts degrading everything, and then your hole just goes all to heck. Um, so, but like you hit that level where water is just kind of seeping in from the sides and under the ground, right? That's that's the water table level. And basically what that is you've gotten down to a point where water, um, for one reason or another, probably because of some kind of a confining bed or something, but that's the point where um, the water has sort of like soaked up through it. So imagine you had like imagine you had a jar with like rocks and sand and stuff in it, and then you filled it about halfway with water, right? The water would go about halfway up, and if you dug down to that point, you couldn't like get the water out because that's the level that the water's at, right? That's the lowest level. The water doesn't have anywhere else to go really. That's basically what the water table is, and when you hit that. So when you when we dig a well, uh, if you're out in the country, most people have wells. When you dig a well, what happens is you're essentially doing what you do at the beach. You're digging a deep hole. Um, so hold on, maybe I can. I wanted. I didn't want a picture actually. Ground water. Okay, here we go. Yep. So essentially, what you're doing is you are tapping down far enough into like below that water table. So water automatically seeps into the hole that's dug, and then you have pumps down here that pump the water up into your house, into whatever. So um, so that's essentially what the groundwater, that's how groundwater works. Okay, now where does all of that come from? Well, like we mentioned, all of the water that comes from precipitation with rain, snow melt, um, things like that, right? So all of that stuff at some point comes from quote unquote above ground, and then it filters down. The Earth actually acts as a really giant filter. Like all the dirt, I know it seems kind of weird. Like you're like, okay, dirt is, but it is like the dirt and rocks and everything act as a filter to kind of pull stuff out of the groundwater, or at least most of it, from like rain and things like that come down. Now, if whoa, what the? Okay, I don't need the shot now. Thank you. So let's go to this now. What is leachate? Well, leachate is when water, rain, etc., mixes with trash and dissolves many substances into the water. Leachate is typically very environmentally hazardous, especially if it reaches groundwater sources. So what happens, and this is why they don't want you to throw certain stuff away. One of the reasons they don't want you to throw certain things away in trash, because if it mixes with water, water can dissolve it, and then um, it doesn't filter out. So like filtering is removing things based on the size of the particles and stuff. When something is dissolved, it doesn't filter out through like filtering, so it'll stay with it. So like say for example, I'm trying to think of uh, what you could have. Um, like you get like heavy metal ions or stuff where they get dissolved in the water, um, like lead or mercury or stuff that like that. Like, I'm not talking about like a chunk of metal. I'm talking like the ions that get dissolved in the water. Um, if that is in there, that is going to pass right through with the water into the groundwater. It's not going to get filtered out. And that's where we get our water from. And if you live in town, you're like, well, I don't have a well. Well, town water gets its water from the same places that wells do. It's just a little different. They'll either get it from like a sometimes they'll give it from like a river, from like rivers or lakes or whatever. But usually there's just some kind of a like an aquifer or river tap that comes at one point it was from groundwater. So now typically when you have water in a town or a city or whatever, it's typically run through cleaning and sanitizing uh, methods or whatever, but it still could be polluted. Um, so depending on like if there's different kinds of pollution that they normally don't account for, I guess I should say. So that's why leachate is can be really harmful. So you get water coming down in a dump, dissolving different types of hazardous things, and then it just sinks right through the ground, and it can get into groundwater and stuff like that. So that can be a big problem with those. All right, sanitary landfills. So first of all, what is a sanitary landfill? It's a newer style of landfill designed to eliminate most pollution. It keeps trash in separated cells and has a plastic liner system to prevent groundwater contamination. So there's different examples. Let me right. Oops. So sanitary landfills. Um, let's see if I can get that any bigger. Oh, oh, there we go. Okay. So you can see like sanitary landfills, they separate the trash into like sections or cells, and then they kind of like cordon the cells off um like seal this like each like the individual cells. Um, they also have this is kind of hard to see. Let me see if there's another picture that shows up a little better. Oh, um, yeah. Okay, I guess these are still about the same. So there's these are a little different. These are showing a little more advanced. Like there's a clay layer, there's a plastic filter layer, a leachate collection layer, that thin layer in between, and then there's like gravel and a plastic liner. A low, like it's called low permeability layer. Permeability means the ability for things to get through it. And if it has low permeability, it means things can't get through it very easily. So in your book, it has an example too, which you'll be able to, because I can zoom in here, you'll be able to see a little better, but it's not quite as involved, but it had the idea here. Hold on, let me see if I can. Okay, so you've got like so they're showing here. This is like a little different, but 6 to 8 inches of fill dirt, and then you've got like this filtration system of like gravel and filter different filter layers. Then 24 inches of compacted clay. Which what does a compacted clay do? Yeah. That's like your base. That's going to prevent stuff from like going through it because clay's really dense, and then you compact it on top of that. It's going to be very dense. Um, and then you've got like plastic liners, and then you've got within this like filter, like the filtration part here, you've got tubes that help draw off leachate or anything that gets down there, which is kind of what these were showing. This layer here would have tubes then that go out and take any leachate to collection to tanks, or sometimes they have like leachate ponds. Um, Let me see if I can.
Like what we saw yesterday.
Yeah, yeah, that. So leachate ponds, or like we saw yesterday, was the trenches, right? Um, so these are collection ponds um, where essentially hazardous, mixture of water and hazardous substances are stored and treated. Um, they store and treat them in these collection ones, um, so the water doesn't get into the groundwater. Okay. Um, so that's kind of the basics of the sanitary um, of a sanitary landfill. Now, benefits to sanitary landfill, kind of what you would expect, right? Less pollution, no leachate contamination of groundwater. Oh, all also almost all landfills now have some sort of monitoring wells drilled around like around the perimeter of them. Monitoring wells drilled into groundwater that are continually monitored and tested to make sure that nothing is escaping into the groundwater. Um, so less pollution, no leachate contamination to groundwater. Those are the main. They're more efficient in terms of like use of space too, to some extent. Drawbacks: they're more expensive to maintain because there's more going into it, right? They're less convenient. Again, got to do more work with it. Um, Siting issues: no matter no matter what kind of landfill you have, just in general, you're going to have siting problems because nobody wants that near them. No, it doesn't matter if you know, it doesn't matter if it's sealed up in a concrete tomb. Nobody really wants trash in their backyard. Okay. Um, and slower decomposition. Here's something that I didn't know before I started teaching this that really kind of it was somewhat shocking. Um, so I guess I should first ask: do you guys do you guys like had experience, like, what a phone book? I know you know what a phone book is. Do you know what like the paper feels like and like the kind of paper they use in them?
Yeah, like that.
Like the super thin, like almost like tissue paper type, right? Like
I know what kind of
yeah, like really cheap, right? Okay. Yeah, 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 right. Okay. So if you were to like leave a phone book outside for any length of time, like less than a week, it's already going to start to break down. It's probably going to become unreadable and stuff like that, right? Because like the paper's just really cheap and really thin, and it's going to break down. They actually talk in your book here about. Let me see if I can find it. Yeah, here. There was a group of people that were studying, like, I don't know if they're like sociologists or what. They say archaeologists from the University of Arizona have been carrying out research on old landfills. The research has shown that even materials formerly assumed to be biodegradable, such as newspapers, wood, and so on, are often degraded only slowly, if at all, in landfills. In one landfill, 30-year-old newspapers were recovered in a readable state. So newspapers are very similar, right? Like cheap paper, they don't last very long if you have them. 30-year-old newspapers, and you could still read them. Layers of telephone directories, telephone books, practically intact, were found marking each year. They were actually able to use, like, that's their version of carbon dating, is like finding, they find a layer, they find the telephone books from that layer, and they know what year that stuff, the trash was from, because they can still read them and they're still intact. So um it's it's kind of mind-blowing how little decomposition goes on in these sanitary landfills. Um, so yeah, go ahead.
Well, I think when you think about it, you're kind of, when they're burying it all over to put the dirt back on it, it just creates a cap. I mean, I don't see how they would think that it would decompose any faster if they put the cap over it. But rain is like a natural, like water
Yes,
is a
good.
natural decomposer of
Yep.
stuff. So
Yeah, that's exactly what I was going to ask is like, why do you guys think that is? And that's exactly right. Because the things that help decompose, help things break down and decompose are sunlight, water, exposure to oxygen and air, right? So exactly what you said. I don't think that they think that, like, I don't think that they're surprised and being like, oh, it should have decomposed faster. Like, I think they know that it's not decomposing as fast. But I was surprised by not that it didn't, but like just how little it did. You know what I mean? Like just how little breakdown it had. Um, but yeah, exactly what you said. It makes sense if you think about it. You're sealing all the trash off to make sure it doesn't get into the environment and pollute anything, right? You're sealing it away. Well, if you're really good at sealing it away, it's going to last like a time capsule, right? It's going to last for a really long time. If you're keeping all the air, oxygen, water, sunlight, all of it out, it's not going to break down, right? So that is a problem with trash if especially if a lot of that could break down and it's not. Okay, so those are some of the drawbacks. Now let's just keep going with this into some of this. So we talked about leachate creation and groundwater contamination already as one of the problems. Methane production. Anybody know why you get methane production in landfills?
it's just part of decomposition.
Specifically because
Uh,
there's no oxygen.
oh,
Yeah. Methane is produced when you get things breaking down without the presence of oxygen. Okay, not to be like crude, but gas like from animals or people or whatever comes from it comes from our um, like bacteria and stuff in our intestines and guts and stuff that are breaking down stuff that wasn't broken down otherwise by our body, that our bodies it was hard to break down, and it's breaking it down, but it's breaking it down inside of our body when and without the presence of oxygen. So gas is produced, methane gas. Same thing with cows and other animals like that and stuff. It's stuff being broken down without the presence of oxygen. Obviously, sanitary landfills that is any kind of decomposition is done is without oxygen because you've sealed it off, right? So, what's the problem? Well, methane is highly combustible and poses an explosion risk. It's also a greenhouse gas that's like I forget what the number is, but it's like way more potent of a greenhouse gas than like even like carbon dioxide and stuff. Um, so you're basically creating underground pockets and stores of highly combustible uh, gases and also what's another byproduct a lot of times of decomposition? Heat, right? A lot of times, so you've got highly explosive gas being produced and heat. Yay! You get garbage fireworks. Uh, so, uh, so what do they do? Um, what's one of the things they do to help this not be a problem? Yeah, you guys were talking about this the other day, right? So this is what you guys were talking about. Okay. Um, you see, now these are different versions of it, but what you guys were talking about, if you go like on 88 or on any of the north-south roads that go by the landfill in DeKalb, you'll see um, basically you'll see these like torches sticking out of the ground. Some of them are these are a little bigger. Some of them are smaller. Um, like they'll look something kind of like this or like that, kind of like this. Well, no, it's still kind of big. And they're usually not, they're not super huge, uh, but you get the idea. Basically, what they are is essentially they're almost like a well drilled down into like a tube rudder drilled down into the landfill that helps gases, the methane gas escape into it. It essentially collects the methane gas from any decomposition that does happen, and then as it comes up that torture tube, then it's burned off, so it doesn't that's to so it's not escaping into the atmosphere as a greenhouse gas. So is burning it great for the no, not 100%, but it's way better than letting it just escape in the atmosphere. So now here's something that some places are going to that's uh, that's even better. There are some places that actually have built designs where this looks like a simple one here. Yeah, they use the methane gas. Um, they use the methane gas and they collect it, and then they burn it in generators to create energy. I mean, if you think about it, that's a pretty nice way of using that. You're getting something that's going to be produced anyway. It's a byproduct that you don't really want, and if you can turn that into something beneficial, that's a pretty good deal. Yeah.
I don't know why that they haven't started doing them because methane is just such a byproduct. I don't know why they don't do this. I think this would be smart.
Yep. It
I don't know if it would make money for it. I don't know.
it well, I mean, it would eventually. I think my guess, and I'd have to do a little more research, but my guess is initially like the initial cost probably is like because you have to create you'd have to build the generator, yeah, the generators and stuff and the combustion chambers to burn it, and then the generators, and then you'd have to have some kind of uh like infrastructure to then either use and or deliver the energy that's created one way or another, you know. So my guess is the initial startup would probably be somewhat expensive, but over time I mean it should, and I guess it depends on how big it is and how much methane is produced. Like if they're not producing a ton of methane, it might not be worth it in terms of like the overall amount. But if they had bigger landfills and they could get, you know, um they could get this, it's a really, yeah, smart use. So along with this, something else that came up a couple of years ago that I had never known about. Um, has anybody ever heard of a farm digester? It's it's super interesting. We actually learned about it in the energy one a little more. In they use this a lot in kind of poor countries. Um, it well, okay, these are like bigger, like these are like more technologically advanced one. Um, let me see if I type in simple. Basically, what it is it's a chamber or something, and some like in a lot of poorer countries they'll use these. Uh, and basically, what it is it's like a big chamber where they put waste, and then the waste produces the breaking down of it produces methane, and they have either a way to collect it or on top of it they have a essentially like stove or whatever, and they use it to help cook and boil water and cook things and stuff like that. It's really kind of ingenious if you think about it, especially in these poorer areas where they have it's harder to access like clean water, so they got to like boil water, and so they need fuel for that kind of stuff and fuel for cooking and things. And if they are raising livestock or whatever, it's sort of like one of those um, the more traditional style, then using that is very it's actually a really good in terms of sustainability and usage of the stuff. Yeah,
Do they sell bottled methane? So,
bottled methane.
yeah,
I mean,
taking this off, this would, like, if for boiling water, you know what I mean? Like,
yeah, I'm sure. I'm sure they would for certain things. Like I'm sure they would sell canisters of methane for certain applications. Um, I think it'd be very specific, like what people are using it for. In general, probably not as much because it's just not very stable. Well, yeah, and it's not stable either, really. It's like hydrogen. Like, do they sell like hydrogen canisters, hydrogen stuff? Yeah, for certain applications, for uses in certain things. But in general, no, because it's not a very stable energy source. Like, yeah, like diesel and stuff like that is really stable. Even though it's pretty flammable, like something like butane or propane is still more stable than like methane and stuff like that. So. Um, yeah. All right. So let's see. So that's methane production. Settling. Trash sites over time can settle and create uneven landscapes and even sinkholes. They can pose hazards to human use of land as well as drainage issues. So, like, um, again, sinkholes. I'll bring up some pictures here. Um, so they can be very large, um, and and very problematic. Oops, I need to, oh, it's fine. I mean, you can see. So that's so. What happens is as stuff um, as stuff builds up, or I mean, sorry, as stuff breaks down, the stuff that does decompose, and you just get stuff settling over time. That basically creates like an empty gap area underneath the earth, which then can collapse. Um, which here's a thing kind of showing, um, or that might be how they fix it. I don't know, but and it especially happens if stuff sinks into like the groundwater area or underneath, like because then it kind of collapses down in and like that stuff washes away. So it can be even it's a really big problem if it kind of reaches into the water table, and then here you go. Let's see if this one pops up. Yeah, come on. Oh, for the love of God. Well, anyway, you can see it in here. As it like, and then just basically it's like everything caves out from underneath it and it just collapses down. So, so sinkholes can be a problem. Um, we talked about incomplete decomposition a lot already, which means stuff isn't breaking down, which means it's still there years and years later. And then the last one is pretty obvious as well. So NIMBY, the acronym NIMBY stands for Not in My Backyard. And that's no, like I said, nobody wants a landfill near them. Even the newer sanitary ones, the new sanitary ones it still smells. It's still, you still get stuff like that, and nobody really wants that. So siting issues, and then that means that a lot of them get put in areas with few people or with people that don't have the ability to successfully reject the siting, poor and minority. We talked about environmental racism before a little bit, right? Like I mean, you're not going to go put a landfill in the middle of Naperville, like get all the soccer moms unite, yeah, right? Not near my baby, like so. So it's gonna be put where people can't reject it. So, um, what do we do to improve these? Well, there are some things here. We've talked about the floor and sides covered with plastic liner contour to keep leachate out. New landfills are sited on higher ground, well above water tables, so they try to keep them away from water tables. Um, Built in the shape of a pyramid and capped with topsoil and seeded. What does the pyramid shape do? Well, the pyramid shape helps shed water away from a landfill. Think about roofs, right? Why are roofs why are roofs peaked like that? Well, they're peaked to allow rain and snow and stuff to shed off and not to just accumulate, right? Same thing with a landfill. If you don't want water seeping down through and absorbing stuff, put it in a pyramid shape. It runs off the sides instead of runs down through. And then we already talked about surrounding the site with groundwater monitoring wells just to ensure no pollution's getting out. Okay. All right. What time do we? 37. Okay. Let's stop here for today.